Oops. All right.
Hey guys, we are finally on the last section of Chapter 5. We made it. Whew! There's not a whole lot to this section really. We only got 2 slides in the presentation today, and I mean it's a fairly strong concept here that you need to catch, but there's not much to it. Just these 2 slides to talk about it. Really, it's just a theorem and its converse. So it is called the Hinge Theorem. And so this is section 5.6, and that's what it's titled actually, the Hinge Theorem. And so the Hinge Theorem is very much so like kind of like our SAS theorem from last chapter in proving triangles congruent, except that we're not proving triangles congruent. We're showing that there's an inequality going on, like the rest of the chapter that we've been talking about. So the Hinge Theorem states that if 2 sides of a triangle are congruent to 2 sides of another triangle, but the included angle is larger than the angle in the other triangle, then the third side has to be longer than the third side in the second triangle. Okay? That's a little bit hard to say in just words and be able to catch what it means. So let's look at this diagram right here. And so if we're comparing those 2 triangles, and we see that Vx in the first triangle is congruent to RT in the second triangle, right, because they're both marked with a single hash mark. VW is congruent to RS in the second triangle, because they're both marked with 2 hash marks. But yet the angle, the included angle, like we talked about with SAS, the included angle is definitely larger in one triangle than it is in the other. That forces that opposite side, XW, to be longer than the side in the second triangle, ST. And so that's the conclusion at the bottom of the diagram there, that WX has to be greater, the length of WX has to be greater than the length of ST, because that angle is smaller in ST. Therefore, the opposite side has to be shorter. Okay, so I think it's obvious or semi-obvious from the diagram here, and I don't know if it'll throw you at all, the fact that we can have 2 congruent sides like that, and then not have congruent triangles. But you need to see the fact that you can have 2 congruent sides, but the angle between them is considerably different. That's what makes the sides different. Anything else there?
Yeah, I mean, if you guys want to, you can test this one at home when you're looking at it. Just go to the door of your bedroom and open your door of your bedroom, and you'll see that the farther you open that door, you can make a triangle between the opening, between your door jamb and the edge of your door. And the farther you open your door up, the longer that opening gets. And if you almost close your door, you'll see that that opening is only about that big, and then as you open it wider, it gets bigger, gets bigger, gets bigger, to where the length of your door is the same. The length of your door jamb is still the same, but as you open that door farther and farther, that third piece gets bigger and bigger, or as you close the door, it gets smaller and smaller. So it's kind of this idea of, here's my door opens like that, there's that third side in between my fingers. Kevin, can you put your like that? And so now, as I open that door further, now Kevin's finger can't reach there anymore because that third piece has gotten longer. So that's just what the third or the hinge theorem is really saying is as you know, that's why it's on a hinge. Your door's on a hinge, and as you open that hinge even further, that third side gets even bigger. And so you can kind of make an inequality, like at the bottom of the diagram there, of WX is greater than ST.
That's why it's called the Hinge Theorem.
Yeah.
The hinge on any door opening like that, that's what happens is you open the door bigger and bigger. Okay. So the converse also works. The converse of that theorem also works, that if you know that we have 2 sides congruent in one triangle to 2 sides in the other triangle, and you know the opposite side is longer, so in this case the side opposite angle C is 12 compared to the side opposite angle F is 9, that means that angle C has to be a bigger angle than angle F, even though the sides on either side of the angles are congruent. That angle has to be greater if the side opposite it is greater. And so the theorem works both ways. And so we really could make a biconditional out of it. It could be an if and only if. But that's the Hinge Theorem, and the converse of the Hinge Theorem. Works both ways.
I mean,
all right?
Like a lot of other things in this, I would say that this is one that, you know, really relies on some common sense.
It does.
To just try to look at this and say, well, hey, C definitely looks like it's open more than F, so that makes sense that AB is 12 and angle C is greater than angle F, because angle F only opens up to a 9 whatever gap, you know.
Right.
And so it's just a lot of common sense here, guys.
Yeah. But you'd have to be careful that the sides do have to be congruent, because if they weren't congruent, then that would change the whole thing.
Definitely.
So,
definitely, that's a great point. Always make sure those sides are congruent.
yeah. All right.
All right, so we're going to just make you practice this a little bit more, give you a few examples just so you can try to, wrap your head around this a little bit bigger. But here's in example 1, we're given that ST is congruent to PR, which it shows in the drawing there with the hash marks, and then it asks the question, how does angle PST compare with angle SPR? Now, let's go back to what Mr. Scritchfield just said on the previous slide. He said you got to make sure that you have 2 congruent pieces here, and the second congruent piece is not labeled here, guys, so you got to make sure that you recognize what piece is the second congruent piece, and that is PS. So you got to put PS in there first to get that second piece of the Hinge theorem to actually work. So now we know that PS is congruent to PS and TS is congruent to PR. Now we can look at that 24 and that 23 and kind of move back across to the angles opposite them. And if we go this way and go back to this angle right here, and we go this way back to this angle right here, you can clearly see then which angle would be larger. Okay, so having said that, you can make the assertion, now I'm going to switch back so the arrows are going to go away, but you can make the statement then that the measurement of PST, okay, will be greater than the measurement of SPR. And so I would, if I was trying to just label the drawing, guys, the way I would do this, the way I would do this would be just to go like this. I'd put the fact that this one's bigger, I'd put 2 arcs right there. And since this one's a little bit smaller, I'd put 1 arc right there. So that way I could just have a visual of, okay, angle R or SPR is definitely smaller than angle PST. Okay, just another way to think about it if you wanted to, make a difference there on your drawing, so that way you had some visuals there for yourself. All right, so let's go to the converse now. Okay, so now if I have this piece again here, now I'm saying if the measurement of angle SPQ is less than the measurement of angle RPQ, then what statement can we make? Now once again, we only have one piece, okay, of the Hinge theorem. Remember, we need those 2 congruent sides in order for the Hinge theorem to work. So, let's not do that. Let's bring this back in and let's add in that reflexive piece, which is this right, this right there. All right, and so and so now we have P. Let me shrink this down here. We have PQ is congruent to PQ there based on the reflexive property, and now I'm also gonna adjust the drawing to make room to make this and this on my drawing. So I have the measurement of SPQ is less than the measurement of RPQ. So SPQ is less. So I'm going to come here and put one little arc there, maybe. All right, and then RPQ is going to be a little bit bigger, so I'm going to put 2 hash marks here to symbolize that that angle was larger. So now it's just a comparison of 2 and 1, so now I just shoot across to the opposite side, like so. And let me change the color here so I don't get too squirrely. So then, hopefully it's going to let me do it. Oh, nope. Okay. Well, yeah, I don't like you. Sorry guys, there's just one dead spot on that PowerPoint. It's not letting me do what I want. But you can kind of see that angle RPQ is bigger than angle SPQ, and so then you can make the inequality that those opposite sides of RQ and SQ, you can kind of come up with the idea then, that RQ is bigger than SQ. Okay, and so once again, if that angle on the other side is bigger than the angle next to it inside that hinge, then you know that the side opposite of it is also greater. So, Ms. Scritchfield, anything you want to add?
No, don't get confused with the fact that that inequality symbol is the other way around, because it's talking about the other angle. SPQ is the one that opens up to the short side. RPQ is the one that opens up to the longer side. And then the way this slide was set up, those sides are in the opposite order. So don't let that throw you. Just be paying attention to which side is opposite the larger angle and which side is opposite the smaller angle. So
there you go. Now you can kind of see that, if you shoot that out there, that angle over here is bigger than that side over there is bigger than that side over there. We need to fix that somehow.
Yeah.
So, anyways, all right, guys.
Okay, we're done with this chapter then. So, okay, we'll see you guys in class.
Bye.